Hey everyone, my name is Joseph Jimenez. I am working on Chapter 9, Problem 61, and it says two ice skaters with masses of 75 kilograms and 55 kilograms stand facing each other on a 15-meter wide frozen river. The skaters push off against each other, glide backwards straight toward the river's edge, and reach the edges at exactly the same time. How far did the 75 kilogram skater glide? So I've gone ahead and drawn a little diagram where I put the 55 kilogram on this side and then the 75 kilogram ice skate on that side. And we see that the frozen river is 15 meters total. And the distance, I labeled the distance that the 75 kilogram person is going to go as X because we were because that's who we're trying to find how far they went. And so I'm going to do X minus 15 for the 55 kilogram skater. And these are the initial numbers that are given to us. So we have the initial mass, 75 kilograms, with 0 initial speed, and then 55 kilograms with 0 initial speed. And then they're going to push each other. But one thing to note is we need to remember that because it's frictionless, we're going to treat this as an isolated system, which means we can use the conservation of momentum principle. So our initial momentum is going to be the same as our final momentum. And since these guys are at rest before they push each other, we have it that the initial momentum is 0, which gives us a final momentum at 0. So now I'm going to write the equation that we're going to use to be able to solve for the rest. I'm just going to pause it and go ahead and write that on the board. One second. So first, we're going to start off with our momentum. So our final momentum is equal to 0, and our final momentum is equal to our first mass times our first velocity, initial velocity, or final velocity, plus our second mass times our second final velocity, which is equal to 0. So what we're going to do then is move this to the other side by subtracting it. So now we have our mass 1 times final velocity of object 1 is equal to negative mass 2 times the final velocity of object 2. And then we're going to divide our velocity from this side over to this side. And then we're going to move over our mass to be on this side. So we're actually going to divide 55 over 75 over negative 75, which is going to give us a V1, a velocity 1 over velocity 2 final is equal to 0.73. And from there, we're going to plug it into the next part of the equation, which I'll quickly erase the board and write down, and I'll pause it for that. Okay, so right here we can see that our, what's it called? Oh yeah, so our the velocity of object 1, the final velocity, is equal to x over t, all displacement over t, which is equal. We're going to just move things algebraically around. So we're going to multiply t to both sides to get rid of the t on that side. So we're going to get t times the final velocity of the first object is equal to x, and then we're going to arrange it so that we can solve for t. From there, we can see that t is equal to negative 15x over the object 2, the velocity of object 2's final velocity. So here we have t is equal to x over the final velocity of object 1. Here we have t is equal to negative 15 minus x over velocity of the final velocity of object 2. And since t is equal to t, we can put these two equations equal to each other and then substitute our answer that we got for our initial velocity, the final velocity of object 1, and we can just plug that in. So I'm going to do that, and then I'm going to pause and do that, and then we'll go through the next section of the problem. Alright guys, so right here we put in the value for 0.73 into this part of the equation. So we have the 0.73 times V2F, and that's x, is equal to negative times 15 minus x over V2F. So when I multiply this side to get x by itself, I'm going to get rid of my V2Fs. These are going to cancel out, and I'm going to get x is equal to negative 0.73 times negative 15 plus x. So then I'm just going to carry that out. So it's going to be x is equal to 10.95 minus 0.73x. Sorry. And then from there, I'm going to add this part of x over to the left side. So I'm going to get 1.73x is equal to 10.95. And then to get x by itself, I'm going to divide both sides by 1.73. And then I get, oh, I put that wrong. So then I get x is equal to 10.95 over 1.73, which comes out to be x is equal to 6.33 meters. And that is how far the 75 kilogram ice skater went. So thanks guys, I know that was a lot for that problem, but that's just the way it is. Thank you, I'll see you for the next one.